Hello, welcome to another session of the video coming to you from Ogabo, where we're going to be continuing from question number 1, Northwest Regional Mock 2022 Chemistry Advanced Level. So let's get into the video. Question 21. Which of the following carboxylic acid derivatives is likely to be least reactive with respect to acid hydrolysis? So acid hydrolysis is about reaction of a compound with water, which is mostly nucleophilic reaction. So among all these options, acid amides contain the nitrogen atom which is more electron donating than withdrawing, making the structure more stable and hence less reactive. So the least reactive acid derivative is going to be A, amide, because the nitrogen is electron donating, making the ring or making the whole compound more stable and hence less reactive. So our answer is A. Question number 22. For the group 4 element carbon to lead, select a correct statement. Let's say A. All the tetrachloride hydrolyze in water, which is of course not true, because carbon tetrachloride is insoluble in water because it lacks d orbitals that will be able to form intermediate with water molecules. B. The stability of the +2 oxidation state decreases down the group, which is false, because stability of +2 increases down the group due to tendency of inert pair effect. Once there is inert pair effect, outer s electrons remain paired without taking part in bonding. C. Tin monoxide is amphoteric, while tin dioxide is acidic, which is not true. All the monoxides of tin, germanium are amphoteric. So D. The thermal stability of tetrachloride decreases down the group. The thermal stability of tetrachloride decreases down the group. This is because the +4 oxidation state decreases, the stability of +4 decreases down the group. Hence, the stability of tetrachloride will also decrease down the group. So D is our best answer. Question number 23. Question number 23. The Rutherford gold foil experiment led to the discovery of, normally Ernest Rutherford bombarded gold foil with alpha particles, and he observed the following: that most of the alpha particles pass through undeflected, a few were slightly deflected, and very few, like 1 in a million, retraced their path, and he drew several conclusions from such observations. For most particles that pass through the flow undeflected, shows that the atom is mostly empty space. For the alpha particles that were slightly deflected by smaller angles, shows that the nucleus is positively charged, as is the alpha particle. Then for those that retrace their path, occasionally it shows that the nucleus carries most of its atom's mass. So these were conclusions drawn, and therefore it was to discover the nucleus, making our answer to be D, the position and the properties of the nucleus. Question 24. Which of the following compounds will form a yellow precipitate with iodine and sodium chlorate solution? This is simply iodoform test, and the condition for iodoform test is methyl carbon, or whether a methyl group or a hydrogen atom, that is for ketones and for aldehydes. Or you have a methyl group when the carbon atom carry an OH, R, and hydrogen. This also gives positive iodoform. So our best answer that is feasible that we can see here is this secondary alcohol, because it has methyl, carbon, OH, and hydrogen. So B becomes our answer. Question 25. How many orbitals are present in the p-subshell of an atom? Normally, the p-subshell is a subshell of an atom that takes a maximum of 6 electrons. So if it takes a maximum of 6 electrons, it therefore has 3 orbitals, where each orbital takes a maximum of 2 electrons each. So the p-subshell generally has 3 different orbitals, making our answer to be A. Question 26. which one of the following elements is most likely to have the successive ionization energies in kilojoules per mole? We look at 899, 1757, we have 14,848, we have 21,006. And now, which of the elements should have this particular ionization energies? So what we are observing here is, from here to here, from 899 to 1757, there is a gradual increase, but we realize that it moves from 1,000 up to 14,000, which is a large increase. And this large increase shows that a new shell has been penetrated after the removal of 2 electrons. So if 2 electrons are removed, we talk about valence electrons to determine the group to which an element belongs. So therefore, we're going to be talking about beryllium because it has 2 valence electrons. Question 27. 2 reactions in the enthalpy changes is shown. We have the formation of ethane from carbon and hydrogen, and we also have the formation of ethane from ethine and hydrogen with their various enthalpy changes. They say this data can be used to calculate the enthalpy change for the reaction shown below. We have carbon plus hydrogen giving us ethine, where data H is X. They've asked us what is the value of X. So there's a pretty way to go about it, simple way to go about the question. Let's look at it. So when we look at these 2 equations, we are simply going to arrange so that we have something like this. So how are we going to do to get this? So we are simply going to reverse this second equation. So we're going to reverse it and then add the 2 different equations. So when we reverse this equation, we now have C2H4 giving us C2H2 plus hydrogen. Now that we have this, we can now add this and this. So if you do that, we're going to have 2 carbon plus C2H4 plus 2H giving us C2H4 plus C2H2 plus hydrogen. We're going to see here that this will strike off this, and 1 hydrogen here will take off 1 hydrogen here, so that our overall is going to be 2C plus hydrogen giving us C2H2. So as I swapped this one, the enthalpy change also swapped from negative to positive 175.8. So as we added the 2 equations, we also have to add the enthalpy changes. So enthalpy of reaction is going to be 52.2 plus 175.8, and we're going to have positive 228 kilojoules per mole. That will be our value for enthalpy of reaction, which is a value of X. So our best answer here gives us D. Question 28. Hydrogen iodide gas decomposes reversibly, producing iodine vapor and hydrogen gas. By the equation given, say delta H is positive X, which shows already that it is endothermic. Then I say the position of the equilibrium for this reaction may be altered by changing the external conditions. Which row correctly describes the change in position of equilibrium? They have given the column effect of increasing the pressure, effect of increasing the temperature. So we look at this equation. When we increase the pressure, is there any change? Now the criterion for pressure is that there should be a difference in the number of moles. When we look at the equation, we have 1 mole of hydrogen, 1 mole of iodine produced, and altogether 2 moles of product, and we are also seeing 2 moles of reactant, which is hydrogen iodide. So since there is no difference in the number of moles, pressure is not applicable. So pressure does not affect it. We look at temperature. Since it is an endothermic reaction, an increase in temperature will favor the equilibrium position to shift to the right. So therefore, our best answer is going to be C. Question 29. Cobalt can form the positive ion. What is the oxidation number of cobalt in this ion? So we have the ion with an overall charge of positive. So we are going to calculate the oxidation state of cobalt in this complex. So we can call it X, so that we know that of ammonia, which is a ligand, is neutral, since ammonia is a neutral molecule and chlorine is a charge of -1. There are two chlorine atoms. It becomes plus minus 2, and we equate to the overall charge, which is positive, so that our X is going to give us positive 3. That will be the oxidation number of cobalt. And the name of this compound now is going to become tetraamine dichlorocobalt 3. That will be the name of the complex. So our correct option here is C. Plus 3 is the oxidation state. Question 30. Magnesium nitrate decomposes when heated to give a white solid and a mixture of gases. One of the gases released is an oxide of nitrogen. X. Identify the color of the gas. So when the nitrates of group 2 are decomposed, like magnesium nitrate, we are going to have the product formed to be the oxide of the metal plus nitrogen monoxide plus oxygen gas evolved. And nitrogen gas is the oxide of nitrogen they're talking about, and it has a reddish brown coloration, making B to be correct. 32. Which compound is chiral? So we want to identify a chiral compound, which means it should be a compound where a carbon atom in it is bonded to 4 different groups. For instance, we have something like this, where you have a carbon atom bonded totally to 4 different groups. So we are going to identify from these groups which particular compound will have a chiral carbon. So we can see from the options that A cannot be neither B nor D, but C is the best, where this one with an asterisk shows that it is a chiral carbon bonded to 4 different groups, making our best answer to be C. C is the best answer. Question 33. The 5th to 8th ionization energies for 4 elements in period 3 of the periodic table as shown below. Which row refers to chlorine? So for chlorine, it can be able to have successive 7 ionization energies because it's got 7 electrons in its valence shell. So it can undergo 7 successive ionization energies. Now, we have to understand that we are moving from the 5th to the 8th. So, after the 7th electron has been removed, it will require an excess amount of energy to remove the 8th electron because we've entered into a new shell. So we have to look at the row where there is an increase from the 7th to the 8th, which means that there is a prominent increase from the 7th to the 8th. And we look at this, A moves from 25,000 to 30,000, not that too vast. We look at B, 7 to 8 is 27,000 to 31,000, not too vast. C, 11,000 to 33,000, which is of course a good increase, and it should mark that of chlorine. So our best option becomes C. From 34 to 45, you can pause and read the instructions before we proceed. Question 34. Which of the following statements about buffer solutions is true? We know that the buffer solution is a solution which resists changes in pH upon addition of small amounts of acid or base. 1. They consist of a weak base and its conjugate acid. Yeah, that's true. We can talk about ammonia with ammonium chloride. This is a conjugate salt of the ammonia. So this is a buffer solution. 2. They resist sharp changes in pH upon addition of small amount of a strong acid or base. That is also a true statement. 1 and 2 are correct. They have a pH of 7. This is not certain because you can have alkaline buffers and acidic buffers. So option 3 is out. Therefore 1 and 2 are correct, making our answer to be B. Question 35. The ozonolysis of propene produces, so ozonolysis is about the addition of ozone into an alkene. So we look at propene and we see that when ozone is added to this compound, oxygen atoms will attach themselves here, where this double bond will split. As the double bond split, oxygen atoms will attach themselves on either side, forming two compounds of this magnitude. We have this compound, and we also have this compound, which will all be aldehydes, forming ethanol and methanol. So, making our answer to be 2 and 3. So, our option is C. Question 36. Which of the following compounds will react with acidified potassium dichromate on warming? Acidified potassium dichromate. Potassium dichromate is an oxidizing agent, so it will cause oxidation by the removal of hydrogen. So, acidified potassium dichromate can always act when you have any hydrogen atom that can be replaced or that can be displaced. When you have a hydrogen atom that can be removed, so it can act with this hydroxy. It can act on this hydroxy carboxylic acid because it appears to be secondary. It can also oxidize this methanol, and since the dichromate is an oxidant, it will not act on this tertiary alcohol. It's only going to act on this hydroxy carboxylic acid and on this methanol, making our options to be B. It's just to pay attention to this question. 37. The bond that they give a dash of the HBr molecule is dash, that is pure, than that of HI molecule. They say which pairs of words correctly complete the above sentence. So we want to look about energy. We see that bond energy is actually the energy associated with the particular bond. So we consider HBr to be above HI because we have bromine before iodine. So down the group, bond energy increases for the hydrogen halide due to increase in van der Waals forces. So we are saying that statement 1 is already true because bond energy of HBr is greater than that of HI. So line 1 is already correct. Now line 2 says length. If the bond energy is stronger, therefore the individual atoms are going to be held tightly together, shortening the distance between the two atoms. So the stronger the bond, the shorter the bond length, which is also true. 3, they talk about polarity. Polarity also decreases down the group. It does decrease down the group due to decrease in electronegativity. Because fluorine is highly electronegative, it is the most polar. The halide is most polar, and the trend decreases down the group because of decrease in electronegativity down the group. Therefore, we are saying that the polarity of HBr should of course be greater than that of HI. So this is also correct. Therefore 1, 2, 3 are correct. And our answer is A. Question 38. Consider the reaction. We have propanol reacting with iodine giving us the product form. The rate expression has been given. Now it can be deduced from the rate expression that reaction is, let's say, 1 second order overall. Second order overall. Is that true? We have hydrogen concentration power 1 and this power 1, and the two powers 1 plus 1 gives us 2. It makes it a true statement. The second one, they say 0 order with respect to iodine. We look at the rate expression. It is not also the concentration of iodine has not been included. So therefore we are going to say that the reaction does not depend on iodine. They talk about molecularity. Molecularity of a reaction is simply the number of reactant particles that are present at the slowest step of reaction. So we are considering the number of reactant particles present. So we have this expression, and we see that two reactants that are possible. So there are 2 reactant particles at the slowest step of reaction, and so the molecularity should be 2, which is bimolecular, not unimolecular. So 3 becomes of. We have 1 and 2 is correct, and our best option is B. Question 39. Question 39. From the following data, we have zinc half cell with electrode potential value, the iron half cell with electrode potential value. It can be deduced that 1. The standard EMF of the cell after coupling is minus 1.53 volt. minus 1.53 volt. Now, is that true? The EMF is calculated as the EMF, the electric potential of right hand side electrode minus electric potential of left hand side electrode, where the right hand side electrode is the electrode with a higher electric potential value, which is the iron half cell. Now the other left hand electrode is the anode, which is the zinc half cell. So after coupling, the EMF gives us positive 0.77 minus 0.76, which is going to give us positive 1.53 volt. So here is negative, means that 1 is off. 2. Iron 3 is a more powerful oxidant than zinc 2. Now an oxidant is a species that becomes reduced in a reaction, and the half cell from which the powerful oxidant will be chosen is the half cell with the highest electric potential value. So we look at the iron half cell. A species which becomes reduced in a reaction is oxidant. Therefore, iron 3 becomes reduced to iron 2. So therefore, iron 3 is an oxidant, which makes 2 correct. 3. Zinc solid can reduce iron 3. So from the anode, what we're going to observe is a most powerful reducing agent or most powerful reductant, and it is a species which becomes oxidized. So zinc solid should be a reductant because it becomes oxidized in the course of the reaction. So it should be able to reduce iron 3 to iron 2, since it is a good and powerful reductant, making 3 correct. And option 2 and 3 are correct, giving us our answer to be C. Question 41. The solubility of an ionic compound depends on its, there's a 1, hydration energy, which is true. 2, lattice energy, which is true. 3, standard enthalpy change of formation, which really doesn't have anything to do with solubility. So hydration energy for ionic compounds like the S-block element is actually a factor that affects solubility, as well as hydration energy, where the solubility of sulfate, carbonate, and the hydroxide will vary due to variation in either hydration energy and or lattice energy. So making 1 and 2 to be correct, and our option is B. Question 42. Which of the following species can function as chelating ligand? A chelating ligand is that which forms a ring compound with a central metal atom. So let's say it's this metal atom M. This is a ligand L. If it can be able to form 2 coordinate bonds, we now say it is a chelating ligand. 2 or more. So far as it forms a ring with a central metal atom, it is a chelating ligand. So we look at 1. It is ethylene diamine. It has lone pairs on the nitrogen atom. So these lone pairs can be donated to ligands to form a ring with a metal atom. So 1 is correct. We look at 2, the oxalate ion. Opening the structure, we have something of this magnitude, and where we have here negative, negative, showing that there are lone pairs of electrons on this oxygen. So it can also be able to form 2 bonds with a central metal atom. Likewise, EDTA, whose structure is this. So ethylene diamine tetraacetate can also form ring compounds. It has up to 6 groups with lone pairs, so it can be able to form 6 coordinate bonds. So 1, 2, 3 are correct, making our answer to be A. Question 43. Chlorine reacts with sodium hydroxide in 2 different ways depending upon the temperature. Reaction 1, you react to give the chloride and the chlorate, that's chlorate 1. For reaction 2, it gives chlorate 3 and the chloride. So, which statement about these reactions are correct? These reactions are disproportionation reactions where chlorine is reacting with hot alkali and the cold alkali. For experiment 1 or reaction 1, chlorine reacts with cold alkali. For experiment 2, chlorine reacts with hot alkali. So, 1, they say reaction 2 requires a higher temperature than reaction 1. This is what I have just said. It's a true statement. 2, the products of reaction 1 show chlorine in two different oxidation states. That's why we talk about disproportionation. Chlorine is simultaneously oxidized and reduced in a reaction, making it correct. Option 3. The product of reaction 2 show oxygen in two different oxidation states. We are not concerned with oxygen. We talk about disproportionation of the halogens. So statement 3 does not best suit these reactions. Therefore, 1 and 2 are correct, making the answer to be B. Question 44. Which of the following statements about phenylamine is a true? They say it yields nitrogen gas when reacting with nitrous acid at temperatures less than 5 degrees. That's not true. At temperatures less than 5 degrees, it forms diazonium salt. That is, phenylamine is reacting with nitrous acid, giving us a diazonium salt. Nitrogen is not going to be formed when it's below 5 degrees. It is only when the temperature is increased above 5 degrees Celsius, that we are going to have the formation of a phenol and nitrogen gas evolved. So 1 is not correct. 2, it is a weaker base than methylamine. Let's look about it. Yeah, it's a weaker base than methylamine because of the delocalized pi system between the lone pairs on nitrogen and the delocalized system of electrons on the benzene ring, making the electrons on the nitrogen less available for donation, hence weak acid. True. It reacts with ethanoylchloride to give an amide, which is also a true statement. Let's see the reaction. So this will be the product form, the amide and methylphenamide. So our answer is C. Question 45. Which of the processes is or are exothermic? An exothermic reaction is that in which heat is evolved to the surrounding. So we look at A, or 1. These are all gases. These were some small errors about aqueous. They are gases. We look at the bromine gas converted to the bromine ion, which means it has received an electron. This is called first electron affinity, and it is exothermic because heat is evolved. This is enthalpy of hydration. Enthalpy of hydration is also exothermic. This one is actually atomization. 3 is showing that bromine is undergoing first ionization energy to form a positive charge, thereby causing it to be endothermic because atomization requires energy. 1 and 2 are correct, and the answer is B. You can feel free to pause the video and read the instructions from question 46 to 50. Question 46. All D block elements show variable oxidation states. That is statement 1, which is not true. Scandium and zinc are D block elements, but they are not transition metals because scandium forms ions with an empty d orbital, while zinc instead forms ions with a completely filled d orbital. But a transition metal is that which forms an ion with a partially filled d orbital. So making statement A or statement 1 to be false. Statement 2. The 3d and 4s electrons are similar in energy and can all be used in bonding. That's true about transition elements. That is why they form variable oxidation states for transition elements. So it's a true statement. First is false. So our answer gives us C. 47. Phenol is a stronger acid than ethanol. To determine the strength of an acid, you talk about the easy breakage or the easy dissociation of that acid in solution. The more easy the acid can dissociate in solution, the stronger the acid. Because the definition of a strong acid is that it ionizes completely in solution. Now, for the second statement, it says phenyl group has a positive inductive effect and promotes the donation of proton by OH group. So we're talking about positive inductive effect. So for statement 1, phenol is a stronger acid. Since the OH bond, it is easy to lose this proton in solution, unlike ethanol, which has stronger hydrogen bonding. So it is not easy to lose out a proton from here. As a result, ethanol is weaker than phenol. Then the phenyl group has a positive inductive effect and promotes the donation of a proton too. That is why it is stronger. And the statement 2 does explain the first. So our answer here is A. Question 48. The formate ion gives a positive test with tolerance reagent, while the oxalate ion doesn't. It is a true statement. The formate ion has the functional group, this, which is for the aldehydes, and aldehydes are going to give silver mirror test positive. And they say for the formate ion it contains this aldehyde functional group, which is absent in the oxalate ion. Of course, true, and it does explain why the formate gives positive tolerance reagent. So our answer. Question 49. A mixture of propan-1-ol and propan-2-ol can be separated by fractional distillation. Propan-1-ol and 2-ol are already similar compounds with similar molecular weight and similar intermolecular forces. So they are going to behave ideally from Raoult's law. So they are going to obey Raoult's law. And for mixtures that obey Raoult's law, fractional distillation is applicable for their separation. They say because they have different boiling points. Now they say propan-1-ol and propan-2-ol are miscible liquid with close boiling point. That is also true. They have closed boiling point. And the criterion for fractional distillation is if they have close boiling point. So we see that the second one does explain the first, making our answer to be A. The last. 50. Magnesium is harder and has a higher melting point than sodium. This is a true statement due to increase in metallic bond strength as electrons increase from sodium to magnesium. The second one, magnesium is in group 2 while sodium is in group 1. That is also true, but it doesn't explain why magnesium is harder. So both statements are true, but the second one doesn't explain the first, making our answer to be B. So that's the end for this video. If you found this video helpful, please don't forget to subscribe. Don't forget to hit the like button. And then share with your friends. Thanks for watching.